Hey, what's going on, everyone? What we're going to learn today is we're going to learn how to actually rewrite equations in slope-intercept form. Now, what we see in front of us are two equations that there's a different type of way to actually represent linear equations, and this is one of them. We know slope-intercept form is y equals mx plus b. What you see in front of you in both of these cases, they are not in slope-intercept form, y equals mx plus b. What they are in a different form that is actually called standard form. And standard form, it's just another way to represent linear equations. Standard form is denoted as ax plus by is equal to c. And that's what you have in both cases, where a and b are coefficients, and then x and y are still the same, and it's equal to some number or value c. So, the trick is, how do you get it from standard form into slope-intercept form? Truly, not that big a deal. It's just all we're going to be doing is solving an equation. And in this case, if we know that slope-intercept form is y equals mx plus b, we want to solve for the variable y. We want to get one y, and we want to have y by itself on one side of the equation. Okay? Now, we've already done this with solving formulas for a variable. For example, we've already done this with distance formula, where we said, if I want to solve for r in this case, divide both sides by t, because we know that the time, t divided by t, is actually 1, so d over t equals r. We're going to be doing something very similar to that, okay? But it's going to be less with working with variables and more so working with numbers, all right? So let's put it into slope-intercept form. I have a simpler one and a little bit more challenging one. So the first one we're going to work with is this one over here. We're going to work with number 1, and we want to get y by itself. So this is the goal. We want to have y equals mx plus b, because then we know we can identify the slope and identify the y-intercept really, really quickly. Very easy way to do that. If I want y by itself, here's y, and here's just an equation. It's the same thing as we've done with solving any equation, and this time I need to get that plus 0 on this side. Well, the way we do that is we take a look at that 5x, and I can actually make 5x a 0, because we know how to actually work with variables on both sides. If I want to make 5x a 0, well, then I just subtract 5x. And now what I'm doing to this side, if you notice, this is why I draw that that vertical line to show me that's my equal sign. That's one side of the equation. I have to subtract 5x from the other side. I'll draw that in there. Now, if you can see very clearly, I'm subtracting 5x from here, subtracting 5x from the other side of that equation based on that equal sign. That's my fulcrum. That's the center of my equation. So, what I have now, I know 5x plus 5x is actually 0. So this 1y is going to drop down because I do have 1y plus 0, and y plus 0 is just y. Okay? And now we have, this is always the toughest part, but I always think it's the simplest part in solving this equation. You already know that this has a variable x here, where the 9 does not. Well, can you combine them? It's a lot like we said, can you combine a pen and a key? You can't. They're not like terms. So what do we write in? Well, I write in the negative 5x and then plus 9. Now from here, that's actually our equation. And I could rewrite this if I really wanted to. I could change and make this 9 minus 5x. Remember, we can change the order as long as that negative sign stays with that 5x and 9 is still positive. Both are okay. In this case, can we identify slope-intercept form? Well, in this case, yes, we can, because we have y by itself, and this is that 1y. And if that's that 1y, this is exactly the same as slope-intercept form as we have over here. So now it's pretty simple. Our slope in both cases is a negative 5 over 1, and then our y-intercept in both cases is 0, 9. Pretty simple. So now we're going to take a look at another example. This time, not as simple. This was kind of an easier equation, more so because you only had one step to do. All you had to do was move the 5x to the other side, which in this case was subtracting. Okay? Now, in this case, we have 2 steps to do, but not impossible. not too bad. In this case, first thing we have to do is figure out, we want to have y by itself. So y, first of all, is it left or right side? In this case, I see that 5y is on the left side. So that means I want x to be where? Right side. We got to move that over to the right side, kind of like this slope-intercept form. Y equals mx plus b. So in this case, to move this negative 4x, we know that we have to add 4x. And what I do to one side, I must do to the other. So now I'm clearly adding 4x to both sides of that equation. Notice what I did not do was place another 4x in here. Okay? That's bad mathematics. In this case, we've already talked about this. Technically here, 4x and 4x is 8x. You see if they're on the left-hand side there, you're adding 8x here and you're adding 4x here. You're not actually balancing that equation. So I'm going to get rid of that. Because again, bad mathematics. I'm going to draw my line back. And now we actually evaluate. So we're going to go through, and negative 4x plus 4x is 0. So there I can cross that out and just drop in that 5y. So we did get y by itself right now. And then we know here, well, can you add 15 and 4x together? No, you can't, because this does not have an x and they're not like terms. So in this case, I'm just going to rewrite it as 4x plus 15. And that's my expression on that right-hand side. Now, this is the one that's different from the one that we just did over here. The difference here is, do we have one y? No, we don't. So, how do we make one y? We already know the answer to that one. Divide by 5. Now, the trick here, and what a lot of kids get caught up in, is what am I dividing on the other side? Well, multiplication division is a little bit different than addition subtraction. In multiplication, if I'm dividing this side by 5, I have to divide everything on this side by 5 as well. Which means, I'm going to write it down a little bit easier. This is 5y over 5. And that's equal to, technically, the 4x is over 5, as well as the 15 is over 5. Maybe that'll make it a lot easier for us to comprehend. So from here, it's a simple division problem. And we know that 5y divided by 5 is 1y. Okay, we have that 1y like in slope-intercept form. I know, and I'm going to take care of the easy stuff first. I know 15 divided by 5 is a positive 3. And now this is where we always get hung up, this part right in here. So let's actually write in what we know. We know there's going to be an x there because you're not canceling out an x. You're not dividing x by x, so that's still going to be there. And now it's what fraction? Well, 4 over 5, can I reduce it? You always look to reduce that fraction, and in this case I can't. So I leave it as, and we know slope we always write as a fraction, in this case, 4/5. So there's my line in slope-intercept form. All I have to do now is identify my slope is 4/5, and then my y-intercept is 0,3. So here's what we've done. I cleaned it up a little bit so we can look at what our actual slopes and our y-intercepts are in both cases, and then we're going to graph. So this is nothing new than what we've already done. In this case, I've identified my y-intercept. That's the first point I'm going to plot. So I'm going to go up to that 0, 9, and yes, the first thing I must do, obviously, is label my axes. Okay, so I'm going to go up to that y-intercept of 0, 9, so I'll go up 9 on that y-axis, that horizontal axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. Bang. And now we're going to use our slope. So in this case, we know that a slope is our change in our y value over the change in our x value. Or another way to write it is the rise over the run. Okay, but we're going to come back to this guy a lot because that's probably the easiest one to work with. So I'm changing by negative 5, which means I'm going down 5. So 1, 2, 3, 4, 5. Now that's not my point because I still need to change by x right here, which means I have to go over to the right 1 because it's a positive 1. So down 5 again, 1, 2, 3, 4, 5, to the right 1. And then I continue that pattern, down 5, to the right 1. And I can continue this as far as the graph actually gives me. Okay, so I can go down 5 again, 1, 2, 3, 4, 5, to the right 1. And now, what we always look at is we have to make sure that our slope makes sense with what our graph actually is showing us here, which we look from left to right, are our points going up or down. Well, in this case, if I use my pen and I slide it kind of like a vertical line, just like we're doing our vertical line test, is that going up or down if I go left or right? Well, It's going down, so my slope and my answer actually makes sense here. I'm going to draw my straight line. It doesn't have to be perfect, and that is our line, graphed in slope-intercept form. The second one over here, slope y-intercept. First y-intercept I see is 0, 3. So I'm going to go and obviously, yes, label my y and x-axis and go to 0, 3, 1, 2, 3. So I have that point plotted. Now from here I'm going to use my slope. Positive 4 over positive 5, so my change in y, 1, 2, 3, 4 is up 4, to the right 5. 1, 2, 3, 4, and 5. Now, the other way we could do it, if I wanted to, I could make it a negative 4 over a negative 5, meaning from this y-intercept, I can go up and to the right. I could also go down and to the left, and that would be the same positive slope here. So I can go down 4 and to the left 5. Oops, there we go. And then that shows our line in slope-intercept form. So all I have to do now, if I want to go down and to the left again, I could. 1, 2, 3, 4, and then 1, 2, 3, 4, 5. See, if you notice, I ran out of space up here. That's why I couldn't go up and to the right. So then we just draw our line as closely as we can, arrows. And that's how you rewrite and then graph your lines in slope-intercept form.